Hello, welcome to another video for this class. In this video, we are going to study section 5.5 of textbook, which is about right triangle trigonometry. So far, we studied trig functions such as sine, cosine, and more trig functions by looking at, we define this function for an angle. That angle corresponds to a point on the circle, right? Like in this picture, you see the point X and Y. It creates a unique angle theta, and then we said that, okay, for each angle, because this X and Y is unique, then we can define sine and cosine function. We define, for example, sine as the ratio of Y over R, cosine as X over R. So here is the thing. This so far we studied this function, this relationship in the right triangle, and this right triangle we draw it inside the circle. So far in this chapter we started with a circle, and then the point, using a point on the circle, we draw a right triangle inside the circle, and then based on that triangle, we define sine, cosine, tangent, and so on. Now here is a more general version of this. If you don't have a circle, because this was all defined based on a right triangle. So suppose even you don't have a circle and you have just right triangle, okay? So when you have a right triangle in general, regardless of a circle, it is still possible to define these functions, sine, cosine, and tangent. Why? Because look at the way we define this function. What is in fact sine of an angle? We created the right triangle, and then we take the ratio. So these functions are just ratio of sides of a triangle. So even if there is no circle, as long as we have a right triangle, then we can drive and we still can study those trig functions using a right triangle. So when you have a right triangle with angle theta, which is also shown in this picture, then let's look at the sides of the triangle. So this side, we call it opposite. Why? Because this is the opposite side to angle theta. The other side is called adjacent, because this is adjacent to theta, and this is called hypotenuse. Now, look at sine. What was the definition of sine? When you had right triangle in the circle, sine is defined as the ratio of y over r, y over r. Here, it's gonna be, in this labeling, it's gonna be opposite over hypotenuse. That's it. So sine is opposite over hypotenuse. So no matter of the circle, as long as you have a right triangle, if you take the ratio of the opposite side by hypotenuse side, that's gonna be the sine function. And similarly, cosine was x divided by r. X in this case is adjacent, so we can define cosine as the ratio of adjacent and hypotenuse. Tangent, do you remember tangent was y over x, y over x. So in this case, it's going to be opposite over adjacent. Tangent is going to be opposite over adjacent. So in this section, we no longer working with a circle. Instead, we have right triangle, just a right triangle, and we want to still do trigonometry. For example, this is given. Maybe I do this problem. This is example 1. So example 1, a right triangle is given. A right triangle is given. This is alpha, angle alpha, 17, 8, 15, 17, 8, 15. The values of the side of triangle is given. Okay, find the value for cosine of alpha. The question is, what is cosine of alpha? Okay, so recall that we can define cosine. So we can define cosine, we can find cosine by taking the ratio of adjacent by hypotenuse. Okay, so in this case, for alpha, this is alpha, right? For alpha, what is adjacent? This is going to be the adjacent, and this is the hypotenuse. So that's going to be, in this case, it's going to be adjacent is 15, hypotenuse is 17. That's it. So cosine of this angle is this number. So in the next question, okay, I'm gonna, so just be careful, because when you have a right triangle, look, for example, here, when you have a right triangle, this angle is 90, right? Because this is right triangle. What does it mean? It means that this is 90 degree. And we talked about alpha, but there is also another angle. Let's call it beta, right? You can also define things for beta as well, but then adjacent and opposite is going to be different. So for example, for beta, let's say you want to find cosine of beta. Let's also do cosine of beta. Let's say you want to find cosine of beta. Yes, cosine is still adjacent over hypotenuse, but adjacent for this angle. And in this case, I mean, look at beta. For beta, 15 is the opposite side, 8 is the adjacent side. So it's going to be 8 divided by 17. You see the difference? For alpha, this is the adjacent side. So for alpha, cosine is 15 divided by 17. But for beta, because the adjacent is going to be 8, so it's going to be 8 over 17. For example, it says use the triangle shown and find cosine sine of alpha and beta. Okay, let's do this. It's a good practice, like warm up. Example 2. So the right triangle is like this. This is alpha, and this is called beta. And the value of the sides are 3, 4, 5. 3, 4, 5. Okay, let's find, and this is 90. It's 90. It's a right triangle. Okay, so let's first find sine of alpha, okay, and cosine of alpha. Okay, so let's first work with alpha. Sine, find the sine and cosine of alpha. So we know that sine is opposite side over hypotenuse, which in this case is, okay, look at alpha. Now look at alpha. This is alpha. The opposite to alpha is 4, hypotenuse is 3. And the cosine is adjacent over hypotenuse. And in terms of alpha, adjacent is 5, and hypotenuse is 3. Now let's do it for beta. Beta, this is beta. Okay, let's find sine of beta and cosine of beta. For this angle, again, the definition of sine is opposite side over hypotenuse side. Okay, now what is opposite? The opposite is 3 for beta. I'm sorry. I'm so sorry. I'm so sorry. I think I'm sorry. I should have labeled them. I'm gonna fix it. Okay. So far the definition is correct, but my writing is not correct. So let me correct that. Let's go back to alpha. Sorry, this is hypotenuse. 5 is, this side is in front of angle 90. So this is the hypotenuse. Okay, those are the other side. So in the case of alpha, this is alpha. The opposite is 4, hypotenuse is 5. Adjacent is 3, hypotenuse is 5. I'm sorry about that. Now, again, hypotenuse is 5. What is the opposite? Okay, for beta, the opposite is 3. So it's 3 over 5. Again, the definition of cosine is adjacent side over hypotenuse. Okay, again, hypotenuse is 5. Now, for beta, adjacent is 4, is this side. So it's going to be 4. You see that? So in this way, we calculated the trig values for trig function value for these two angles. Okay, so pay attention to the relationship here. What do you observe? For example, here the sine of alpha is 5 over 4. Cosine of beta is also 5 over 4. You see that? They are same. So here, observation is that sine of alpha is the same as cosine of beta. So what is the situation? We are in a right triangle. Triangle has 3 angles. When it's right triangle, one of them is 90. So we are left with 2 more angles. Here we name them alpha and beta. The first observation is that sine of one of them is the same as cosine of the other one. Now look at this relationship. 3 over 5, 3 over 5. So also cosine of alpha, so here we see that cosine of alpha is also same as sine of beta. So it's like if you have sine as, so it's like suppose you are, and here is really the general relationship. So you have a right triangle. So here is the general case. You have a right triangle. So this is 90 degree. And let's name them, I don't know, alpha and beta. Okay. So if you have the sine and cosine of the one of them, let's say you have the sine of alpha and you have the cosine of alpha. Then you don't need any further calculation. You can derive sine of beta and cosine of beta. You just need to switch them. So you just switch them. Whatever is sine of this one, it's going to be the cosine of the other one. Whatever is sine of alpha, it's going to be the cosine of beta. So you just switch these values. So that's the relationship between these two, which is called cofunction identities. Here is also the identity. I'm gonna to get to this identity, I'm gonna do one more step. So you saw that sine of alpha is cosine of beta, right? And also cosine of alpha is sine of beta, like what I put here. So what is the we can even write further. Look, what is the relationship between alpha and beta? Look, here you know that the sum of 3 angles is pi, right? Or is 180 degree. That means alpha plus beta plus this is 90, right? It's gonna be 180 degree. So alpha plus beta is 90. So the sum of these two in right triangle, the sum of these two angles are always 90. So if you want to solve it for B, that's gonna be 90 minus alpha, or in other words, it's gonna be pi over 2 minus alpha. So instead of beta, I can rewrite it as alpha. It's pi over 2 minus alpha. So there we go. Here we got one identity, which is here. Cosine of an angle is sine of pi over 2 minus that angle. And you can have the same thing if you just switch the sine and cosine, like here, okay? So we derive these cofunction identities. Let's use it in example 3. Example 3. Okay. It says, find the unknown size of triangle pictured here. Okay, so we have a right triangle. This is 90. And then we have 7AB. 7 is given. We don't know the value of these two sides. Those are unknown. And this angle is 30 degrees. Okay, we want to find A and B. So first of all, for 30, if you, because the angle that is given is this one, then this is gonna be the opposite side, right? This is gonna be the opposite. This is gonna be hypotenuse, the value for hypotenuse. So recall that sine of 30, sine is defined as opposite over hypotenuse. In general, sine is opposite over hypotenuse. So in this case, I have the opposite. I don't have the hypotenuse, so I'm going to put it B, but I have the sine of 30 degree. We know that. Maybe I do it in the next line. What is sine of 30? It's half. You can also use calculator if you don't have it on top of your mind. And then this was 7 over B. Okay, that's it. From here, you can solve it for B. So B is 14. Okay, so we got one side of this. So we got that B is 14. Now you have a triangle. You have a right triangle. And you know that you have this relationship between the sides of triangle, right? Oops, sorry. You have this relationship. So you know that A square plus 7 square is gonna be hypotenuse square, right? So A square plus 49, what is B? B is 14. 14 square, okay, then solve it for A. Okay, you can use a calculator to do the calculation. So that's gonna be A square root of, when you do the calculation, A is gonna be square root of 174. Okay, now let's look at this example. To find the height of a tree, a person walks to a point 30 feet from the base of the tree and measures the angle from the ground to the top of the tree to be 57 degrees. Find the height of tree. Okay, so you have the picture here, but I'm gonna also draw it here. So you have a tree, there is a tree. So suppose this is the tree. And then this is the ground, right? So there is a tree, there is a ground, and then the person stands 30 feet. So the person is right here, 30 feet away from the tree, okay? So suppose the person stands here. And then the person measures the angle that it makes toward ground, so this angle, right? So because the person look at the tree and then find the angle that the tree makes with the ground and see that this is 57 degree, right? 57 degree. So in this way, we end up with a right triangle. You see that? Okay, so now the question is, what's the question? To find the height of a tree, a person walks 30 feet and measures the angle from the ground to the top of the tree. Find the height of the tree. Okay, the question is, what is this side? What is the height of this tree? Okay, so this is opposite side for 57. And this is 30 feet, this is adjacent. So I have the value for the angle. I have the adjacent, I don't have the opposite. So here we should use tangent of this angle. Why? because we know that tangent is opposite over adjacent. I'm not going to involve hypotenuse because we don't have it. So the best way to deal with it is just having a ratio of opposite and tangent. So if we know what is the tangent of 57, I'm going to do a calculation. We don't know what is the opposite. That's what we are looking for. But we know that the adjacent is 30. And tangent of 57, you can use a calculator. GeoGebra. We need tangent of 57. It's this value. Where is it? It's right here. So let me run that. 1.54. Okay. 1.54. But I run this. So opposite side is gonna be 30 multiplied by 1.54. So basically we need to just multiply 30 by this value. So I'm gonna actually do 30 multiplied by this, 46.2. If you run this, this is gonna be 40, almost 46.2. So you see, here we use tangent in order to do this problem. So yeah, that's it. So basically, if you learned about trig function, this should be very easy for you because it's the same thing, but instead of having a circle, you just have a right triangle. Okay. So I think now you're ready to do the homework assignments for this section. That's all. Thank you for watching this video.